this test that we did last week. So I've put these copies also in the OneNote. But we're going to start with the Part A piece. My recommendation to you is take out your Part A and we'll kind of be going through this. Now, before I kind of dive in here, I want to ask you guys a question. Would you rather I start with just kind of reading through the correct responses, and then we'll go and I have some specific things I want to talk about personally, and I'll certainly take questions and everything from you guys also. But sound good to you guys? All right, I'm going to pause a minute as I hear a lot of papers rustling as people are probably trying to find their Part A multiple choices. If I'm going to read through answers, they probably want them. Cheech, did you find it? Okay. Everybody ready? Here we go. D, B, C, B, A. Am I going too fast?
What's 4?
B, baby. 5 is A. 6 is B. 7 is D. 8 is A. 9 is D. 10 is A. 11 is A. 12 is D. D. Daddy. 10 was A. We're now on 13, which is D. 14, which is B, baby. 15 is C. 16 is A. 17 is A. 18 is D. 19 is C. 20 is C. 21 is A. 22 is B, as in baby. 23 is A. 24 is C. 25 is D. 26 is C. 27 is C. 28 is B. 29 is A. And 30 is B. Repeats on anything that we missed? Jeej? Number 1 is D. All right. Okay, so I'm going to start with questions that were either most missed or most I responded as guess. I didn't know what to do with this. After I've gone and cycled through those, I'll for sure be happy to take additional ones. Everybody cool? Okay. 4 is the first one. When I looked at this, my suspicion was trapezoidal was the issue. So, does anybody remember the area formula for a trapezoid? Okay. It's the average of the bases times the height. So if it wants 3 subintervals, it's going to be the average of those two times that distance, the average of those two times that distance, and the average of those two times that distance. Oops, that should have been 20 plus 60, huh? Ruh-roh. So this is 80 times a half is 40 times another half is 20. This is 100. And then this is 3 over 2. Okay. Where did I? Hi, Lorenzo. Where's my other sheet? Something's going on here. Okay. So this is 100, and this is 1.5, so that's 150, and then divide by 2 is 75. And that's 70 times 1, still 70, divided by 2 is 35. So I think that's 130 then, if we add those all up. I don't know why I was struggling with the arithmetic. It's early, guys. Questions there? In my experience, This is a 2017. I don't know that the trapezoidal piece is on there anymore. That feels like that got discarded somewhere along the way because the more recent things, I don't see any trapezoidal pieces being asked. But it's an easy formula, just the average of the two bases times the height. So just the average of the y's times the distance between the two x's. And you're good to go. 6 is the next one that I had highlighted. And it seemed this phrase came up a couple of times between the 4 parts. This average rate of change seemed kind of clear that we didn't really know what that meant. Average rate of change is just means slope. So this would be like f of 5 minus f of 1 over 5 minus 1. Average rate of change is slope. Average value is an integral. Average rate of change is a slope. Average value is a formula involving an integral. So let's see, if I plug 5 in, 5 squared is 25 times 3 is 75 minus 5 to the third, which is 125, so that's negative 50. And then plugging 1 in, 1 squared is 1 times 3 is 3 minus 1 cubed, which is 1. So 3 minus 1 is 2 over, I don't know why I wrote 5 minus 4. I meant 1 there. I already got jumping ahead of myself. So I have negative 52 over 4, which is negative 13. Ten is my next one. Hello. Audrey, it's for you. Looking at 10, how do we do this kind of an integral? It's got to be a u sub problem, right? So what's our u? X cubed plus 1. So du dx then is 3x squared. So I don't have a 3x squared, but I have an x squared. So I'll divide the 3 over. And then I would recommend redoing our bounds by plugging them into our u. So I do my antiderivative. Now 1 to the 3 over 2 should be pretty easy. How about 9 to the 3 over 2? How do I do that? I'd want to think about it this way. You could do it the reverse, do 9 cubed and then to the 1/2, but like Yuckarooski's 9 cubed without a calculator? No thank you, sir. 9 to the 1/2 is 3. 3 cubed is 27, and 27 minus 1 is 2. So I have 52/9. My suspicion here was this was just needed to be a little bit more careful, right? Probably most of us recognize to try to do this as a U sub. My suspicion is I didn't look at the raw stuff that closely, but I'm guessing a lot of us got 52/3 instead of 52/9 as our answer, and we dropped the 1/3 somewhere along the line there. I don't know for sure though. 11 is also on my list. So it wants us to do the derivative at the point 2, 1. How do I do that? Do you guys remember the name for this kind of problem? So semester 1. This is implicit differentiation. So the problem tells me we're integrating with respect to x. So when I take the derivative of the x pieces, I don't have to do anything special. But when I take the derivative of the y's, I also have to create a dy dx. So I do use my derivative rules, but I also create a dy dx. So the derivative of x squared is 2x. The derivative of xy is, no, it's a product rule. So I have 1 times y plus x times dy dx. Then minus 3 dy dx is equals 0. So far, so good. At this point, I would plug in the values for x and y. At that point, I can see pretty quickly that dy dx has to be 5. So again, on this particular problem, again, I would expect to see implicit differentiation. Super common topic. Have to remember to create the dy dx's when you differentiate, and to look for those product rules. Okay. I almost guarantee there'll be an implicit differentiation problem that involves a product rule at some point in your AP exam, whether that's inside of a related rates problem or just a straight multiple choice, here's a implicit differentiation problem to do. But that thing will occur. We love on the AP exam to try to put, like the chain or product or quotient rule inside of an implicit differentiation situation to make sure you're using your rule and generating your dy dx's. Next one was 13. So first thing I'm going to do is I'm going to look for any stationary points. So any values where the slope is going to be 0. So I see that happens at y equals 4 and at y equals 0. But there's no place where there's an x stationary point, right? So immediately I can cross off A and C, because those would imply x equals 0 should be a stationary, and I do not see that on my graph. Now what I'm going to do is I'm going to observe here that my slope everywhere here is negative. My slope in this region is positive, and my slope in this region is positive. Everybody agree with that? You can tell from your slope field that all those lines are like sloping up or sloping down. So to tell the difference between the two that I have remaining, I'm just going to pick any point in that region and just check to see if it satisfies only one of them. I think it's the thing from down here that's the only one that's going to give you a issue. So let's say that's the point like 0, -1. If I plug that in there, that's negative, right? So that one can't work, just for grins. If I plug it in here, that's positive. That's got to be the one. So on these slope field ones, eliminating, you can usually do some good elimination right away on some answers. It can't possibly be that, just from looking at the stationary points. If you get it down to 2 and you can't tell the difference using just the stationary points like we couldn't here, then you'll want to look at the regions in between the stationary points and just pick points from those regions and see if it satisfies only one of the two choices you have left. You get what I'm saying? Now, if you'd start at the top, instead of the bottom, that would have been you would have gotten them both to work. If you pick the middle, they both work. The only place where you get the disagreement is that bottom section. Um, 14. This might have been, in my opinion, the most involved or difficult question on this. This is borderline an FRQ question to me. So let's walk through this slowly because there's a lot kind of going on here. And you can probably guess as much from reading this, as you have like almost an entire paragraph of story problem here. It says the weight of a population of yeast is given by a differential function y, where y of t is measured in grams and t is measured in days. The weight of the yeast population increases according to the equation dy dt equals ky, where k is a constant. At time t equals 0, the population or the weight of the yeast population is 120 grams and increasing at a rate of 24 grams per day. Which of the following is an expression for y of t? So the first thing I want to do is I want to solve for k. So this information down here at the bottom, I'm going to use some of that. Oh, I guess not that last sentence. It's just the question. I'm going to use some of that to solve for k. This first piece, just is telling me about the weight of the yeast population, right? So that's y. And the second piece is talking about it increasing. That's dy dt. And that tells me also when y is 120 and t is 0 is when that is occurring, right? So if I take that dy dt is equal to ky, I know that dy dt is 24 when y is 120. So that tells me that k is 1/5. So far, so good. So now I have that dy dt is 1/5 y. To solve this differential equation, I'm going to separate it. So I'll divide both sides by y and multiply both sides by dt. And then we'll integrate both sides. The antiderivative of 1 over y is natural log y. And the antiderivative of 1/5 is just 1/5 t. And I need to put a plus c there somewhere. Now what I'm going to do is I'm going to get the y by itself. How do I get rid of the natural log that's in front of that y? I use the exponential base e to both sides. And since it's talking about a population of yeast, I know the population has to be greater than 0, so I can drop the absolute value. Using my rules for exponents, I know that addition inside my exponent is the same thing as multiplication of exponentials with equal bases. So I know now that to solve for c, we know y is 120 when t is 0. So c is going to be the natural log of 120. So putting things back together, I have y to the 1/5 t, e to the natural log 120. I know e cancels out the natural log. So woof, that's a lot of work, right? is there an easier way to have approached this? Because I don't think that the IB or the AP people would have expected you to jump through all those hoops necessarily to get to that answer. Here's what I'll tell you. Oops. If my differential equation is linear, the solution to that differential equation will be exponential. So once I found my k, the coefficient is going to be the initial. So that's probably what they wanted you to recognize. Because if you do that, okay, the initial population is 120. The k, which we were able to find relatively quickly right here, is 1/5. And there's my answer. So that would have been your shortcut. Would have been recognizing that if I have a linear differential equation, the solution to that linear differential equation must be exponential. The k for my linear differential equation, the slope of that linear differential equation, will be the coefficient in the exponent, and the initial population will be the coefficient of my exponential. That would have been the shortcut through it. Does that make sense as to how you would shortcut? Again, I wanted to show you the obvious way to do this and go, woof. Do I really expect to have enough time to even be able to do that? Because that was not going to be fast. I'm only expected like 2 minutes a problem. It doesn't feel like I should be able to do that in 2 minutes. So because that's what I did when I saw the problem the first time, is I did solve the differential equation. Now it's fast enough other places that it didn't really, I had time to spare. But I think that I find it unlikely that the AP was expecting you to do that. This is, I think, an example of a problem that's kind of a time suck, where there's an easy way to do it and a hard way to do it. If you don't see the easy way, it's really time consuming. But this was, I thought, again, was maybe the most in-depth problem. There are lots of places to make like little silly mistakes along the way if you had to solve the entire differential equation. Okay. 15 is our next one. This is a basically, do we know the definition of a limit kind of problem? And can we read the limit or evaluate a limit just from a graph? So it says, which one of these is false? So the first one is the limit as x approaches 1 of f of x is equal to 0. So there's 1. Does that limit exist? Yes, because the right end and the left end are both heading to the same point, and that point is at the y coordinate of 0. So that one's true, right? That's not our answer. The next one, the limit as x approaches 2 of g of x does not exist. So there's 2 for g of x. We see the left and the right limits are heading to different values, so that does mean it doesn't exist. So if I look at C, so the limit as f of x approaches 1 is 0, and the limit as g of x approaches 2 would be does not exist. Does 0 times does not exist equal do not exist? I'm not sure, right? That seems like one of those indeterminate forms. So I don't want to monkey around with that, but if maybe that's right, maybe that's wrong. Let's see from the last one and do this by elimination. So the next one says limit as x approaches 1 of f of x plus 1. So 1 plus 1 is 2. Well, that's just -1. And the limit as x approaches 1 of g is 1. Well, that exists. That's true. Well, that was the one I wasn't sure about, so that's probably the false one because the other ones I'm positive are true. Again, remind yourself, the right answer is on the paper, right? One of those answers is correct. If you can eliminate everything else, you should be left with the correct one. You know what I mean? So even if you get to something like, ooh, I'm not sure if that's right, can I eliminate everything else? If so, okay. I'll go with the one I wasn't sure about because I'm positive on everything else. 16. We want the interval on which it is both concave up and increasing. How do I tell if something's concave up? Has to be. And then increasing. How to tell if something's increasing? First derivative is positive. So we're going to find where those two things occur and then look at the overlap of where those are occurring, right? Because we need both things to be happening. So they thankfully gave us a pretty easy function to work with. So when I take the first derivative, that's 12x minus 6x squared. Now, how do I figure out where that's greater than 0? Yeah, good. So I set it equal to 0. When I solve, I get 0 and 2. So if I make my sign diagram, because this is just 6x times 2 minus x. So if I plug in, if I pick a test value from less than 0, so maybe -1, that's going to be negative times positive. So that part's negative. If I pick something between 0 and 2, say 1, that's going to be positive times positive. That's positive. If I pick something bigger than 2, say 3, that's going to be positive times negative. So that's negative. So increasing only happens between 0 and 2. So anything bigger than that, I know can't happen, so I can cross off D immediately. Everybody's happy so far? If I look at the second derivative, that's going to be 12 minus 12x. Well, I can see there x is equal to 1. So now I know immediately that I can cross off C, right? So if I pick a test value, if I pick something less than 1, say 0, I get 12 minus 0, so that's positive. And then if I pick something greater than 1, say 2, that's going to be 12 minus 24, that's negative. So here we're concave down from -infinity up to 1. The overlap of those two happens between 1 and 2. I'm sorry. That's not right. Between 0 and 1. Everybody can okay there? Again, we had to remember how to tell something is concave up and concave down, and then figure out how to find those regions. The sign diagram, though, is your best friend on anything like that. Make a sign diagram. Usually, if it's polynomial, it's pretty easy to deal with, particularly in a no calculator situation. I don't think they're going to give you like any kooky signs or cosines or exponentials or something like that that's like really difficult to deal with. 17 was the second most guessed question here. I'm guessing because you ended up having to solve a trig equation and you just didn't know what to do. So let's go through that because it's not so bad. So we're given a position function, x of t, and we're asked the first time where t is, or the first time t at which the velocity of the particle is 0. So what's the relationship between position and velocity? Velocity is the derivative of position. So how do I take the derivative of this? 12 e to the negative t sine t. It's a product and a chain, right? Because of the negative t in the exponent. So we have 12 e to the negative t, and the derivative of sine is cosine plus 12 sine t, and the derivative of e to the negative t is e to the negative t times the derivative of negative t, which is negative 1. Is everybody okay with the derivative? So we're looking for where the velocity is 0. To solve this, I'm going to factor so I notice both terms have a 12 e to the negative t. So I'm going to apply the zero product property and separate the two parts with the variables. Now, e to the negative t is exponential, right? With no vertical shift to it. I know that has no solution. Because if I take a number that's not 0 and I raise it to a power, it's never going to equal 0, right? If I just think about this logically, if I have 2, what power can I raise 2 by so that it's equal to 0? Well, nothing. So it's got to be this piece over here. So I'm going to add sine to both sides and then divide by cosine. It's going to leave me 1 equals sine over cosine. Hey, what's sine over cosine? That's tangent. And what's the first value on the unit circle where tangent is equal to 1? So it's pi over 4, right? Because it's the place where you have the 45, 45, 90 triangle where sine and cosine are equal. Or if you think about on the unit circle, it's got to be like that spot right there where x and y are the same. Which is the 45, 45, 90 triangle position. That's pi over 4, 45 degrees. I'm assuming it was this piece that was the difficult part for us, maybe even recognizing that. Maybe it was not straightforward. Although we've done that in class, or we've solved these things looking for critical values and stuff with exponentials tucked in there and going, no solution to that part, moving on. But that's a good one. All right, on to 19. This one had a lot of guesses, although you guys, most of us seem to get this right. This was one of the most correctly responded questions, even though it said it had, a lot of people said they had to guess on this. Yeah, when we say approximation, what are we talking about? We're approximating the value for a function. We're going to use a tangent line to do that. Oh, in fact, it tells us to do that. So let's start by writing that tangent line. The slope we're going to get from f prime of pi over 2. So the f prime is going to be negative 2 sine, and then pi over 2. What's sine of pi over 2? On my unit circle, pi over 2 is there. So sine is 1 is correct. Now, we have the x value already, but we don't have a y value for my point to write my tangent line. Right, I need a point and a slope. We have the x for the point, but we don't have the y. Oops. Let's write it that way. And if sine is 1, I know cosine has to be 0, because sine squared plus cosine squared is equal to 1. So we can say y minus 1 is equal to m times x minus pi over 2. So this is going to be y equals negative 2x plus pi plus 1. If I do y of 1.5 now, negative 2 times 1.5 is negative 3, and then plus 1 is negative 2. So I have negative 2 plus pi. That's my C. So again, you're seeing some unit circle stuff in here mixed in. We've told you a bunch of times that we have to have that thing memorized. But none of these are brutal unit circle values, right? Yeah. They're 90 degrees, they're 45 degrees. They're not trying to test you on the unit circle. Okay? They're really not. You're not going to see like 11 pi over 6, what's that? Like, probably not going to happen. But these like 45 and 90s, those are going to come up. Particularly because on these no calculator sections, because the numbers are easy to deal with, right? There's, you get a lot of 1s and 0s, and that makes life a little bit easier. 20, was one of the least correctly answered questions. And only one person said they guessed on it, so this is one we really need to talk about. So you guys felt like you could do it, and nobody did do it right. So let's talk about how to deal with something like this. So it gives us a function f of x equals x minus 2 over 2 times the absolute value of x minus 2. And it asks us which of the following is true. So if you had a graph of this, could we do this? Okay, so let's talk about how I can generate a graph out of this. If this was just x minus 2 over 2 times x minus 2, the graph is just a horizontal line, y equals 1/2, right? What is the absolute value going to change? Well, what happens if I picked, say, something where x minus 2 is a negative number? Let's say x equals 1. So I get negative 1/2 there. Everybody agree? So until I get to x equals 2, we're just going to look like negative 1/2. And notice I put an open circle at x equals 2. How do I know there's an open circle there? Because it would make the denominator 0. Exactly. Okay, now for values that are bigger than 2, like x equals 3, I'm going to get positive 1/2. So that should be what my graph looks like. So which is true? Is the limit at x equals 2 1/2? Or as x approaches 2, is that 1/2? No. Right? Because it's going to change from negative 1/2 to positive 1/2. Is there a removable discontinuity at 2? Nope. Is there a jump? Yes. Does it have a discontinuity due to vertical asymptote? No way. What do you guys think? So just a little bit of like plugging, looking at what's going on here, thinking about, okay, what would this look like without the absolute value? Okay, what's the absolute value going to do? Try to get a picture out of this. If I have a picture, I feel pretty good about my chances of being able to answer this. Is that, you guys saw how I got a picture out of it? I don't know how you'd plan on doing this without a picture, to be honest with you. Okay. 21 was another one that almost nobody answered correctly, and that's a shame. because this is an extremely easy question. All of you guys, I assume, looked at it and said, I don't know how to do this limit. Let me tell you a secret. This isn't a limit question. This is a derivative question. What are our two definitions for a derivative? There's this one that we used a lot, right? Or there was this one, oops. Look at this, and look at this. I looked at this and said, oh, I just want f prime of 3. What's f prime of 3? 1/3. Done. Easy. Did I actually do a limit here? No. It's just asking me, do I recognize the definition of a derivative, the limit definition of the derivative? It should be a 10-second problem. I almost, again, guarantee you're going to see something probably in the no calculator multiple choice that you can do almost instantly if you recognize that it's the limit definition of a derivative that they're doing. And all I need to do is do the derivative here. I don't have to muck around with the limit. Do you guys get what I'm saying? So again, if it looks like a slope thing with a limit in front of it, because that's what that looked like to me, y2 minus y1 over x2 minus x1 with a limit in front of it. You guys see how it looks like a slope? Think derivative. Okay, that's your cue. If it looks like a slope and there's a limit stuck in front of it, it's just talking about a derivative. Make your life easier. This is a question that you should knock out of the park here. It's an easy question to do. You just have to recognize what it's asking for. All right. 22 was our most guessed question. I thought this was the second hardest question after 14. And I didn't see any shortcut to doing this other than doing your separable differential equation stuff, which stinks, but it is what it is. You guys ready to go? Let's see it. All right, how do I start? Okay, so I'm going to divide by 1 over 2y and then multiply by dx, right? What do you guys notice now? To do the integrals, now that we've separated, what am I going to have to do? I have a u sub on each side. Yuck. I'm going to call one of them v, just so it doesn't get too confusing. Is everybody okay here? Okay. I'm multiply both sides by 2 and plug back in my values for u and v. I'm going to now do the e, exponent base e to both sides to cancel my natural logs. Well, let's just do it this way. Is everybody okay with why it's multiplication of e to the 2c there? That same exponent trick that I pulled earlier when I did number 14. Now, since I know that x is greater than negative 1/2, I know I can drop my absolute value there. And yeah, I'm going to distribute that e to the 2c through. I'll divide both sides by 2. And then if I use my initial condition that y of 0 is equal to e, I can say e is equal to 0 plus e to the 2c over 2. Oh, yeah, that's what I did there. That's okay. So to solve for c, then I'll multiply both sides by 2 and then do the natural log of both sides and then divide by 2. So we can say y equals e to the 2 times natural log of 2e divided by 2 x plus e to the 2 times natural log 2e over 2. And let's look to see what happens. These 2's cancel out. And then this e cancels that natural log. So we're left with y equals 2ex plus that e cancels that natural log, 2e. Crud. I have an extra 2 floating around. Hey, you guys see what I'm going at, though, right? It's got to be this one. That point. Even if we make a mistake, it's almost assuredly have to be that one, right? This was a mess. This I thought was the second hardest one. Now the algebra is the crummy part to it, and there's maybe some sneakier, easier way to do the algebra. I couldn't see it when I was working through it. I don't know. I have to think about it some more to see if there's an easier way to algebra through that. But that's why that one stunk. 23. Not a lot of correct responses on this. My suspicion was because we had a hard time drawing our picture to be able to do the problem. Y equals 2x is going to look like that, right? Straight line through the origin, slope of 2. Y equals x squared is a parabola. It's going to look like that. We're necessarily going to be interested in the area enclosed. So we need to know where x squared is equal to 2x. So 0 and 2. Well, obviously 0, 0. I kind of knew that to start with. The other spot is up here. That's got to be 2, 4. Like when I plug 2 into either one, I get 4. Now it says here that each cross section perpendicular to the y-axis, so like that thing is our cross section, is a rectangle whose height is 3 times its base in the xy plane. So it's a rectangle, so it's base times height. But here we're told the height is 3 times its base. So this value here is going to be x's, right? It's like x1 minus, or x2 minus x1, right? So I know this piece, I know y is equal to x squared. So x2 is the square root of y. And similarly, I know that y1 is equal to 2x. So x1 is y over 2. So we have then the integral, or 3 times integral from 0 to 2 of our b, which is root y minus y over 2 squared dy. If you don't start that with a picture, I don't know what you're going to do with it. Got to have a picture to start. Jacob?
B0 4.
Oh, yes, thank you. Yeah, of course. Thank you. I don't think we had a 0 to 2 option for any of the y ones. But great. Yes, 100%. Yeah. Okay. 24. Lots of us got right, but there were a lot of guesses on this one as well. So this was another, we made lots of guesses. Average value on an interval. That's a formula. 1 over b minus a, integral from a to b. So we know then this is 1 over 6 and that's equal to 12, right? This is the same thing as 1/8. Everybody see that? I can just pull that 1/8 out front. So I'm going to multiply by both sides by 6 over 8. That'll get rid of the 1/6 out front and replace it with a 1/8. Everybody feel good there? Now he says 6 over 8 times 12 is just 9. So again, recognizing our formula and then what we're trying to get to, really easy problem to do. The presentation was a little unusual, right? But if you recognized what was going on, oh, I just multiplied 12 by 6/8. Like, whoa, pretty easy, but recognizing that was not trivial. 26. So if you look at 26, this is, if you try direct substitution, it would be indeterminate, right? You're going to get infinity over infinity. Here's what I'm looking at. If I look inside this piece, inside the natural log, which is growing faster, the e to the 3x or the x? The exponential is growing much, much faster. So I'm just going to kind of ignore the x part. Because it doesn't matter, because e to the x is growing so much faster than the x, it doesn't even matter. So what's the natural log of e to the 3x? It's 3x, right? So this problem is really the limit as x approaches infinity of 3x over x. Well, I know that's just 3. You could L'Hopital this. It stinks to L'Hopital it. They want you to look at it and go, okay, the linear part doesn't matter compared to the exponential. Forget about the linear piece. I can clear that natural log and the e, 3x over x, I can do the limit of that. Piece of cake. Again, you L'Hopital this and you're going to be, the derivatives aren't, the derivative of natural log, e to the 3x plus x, and then simplifying that down to a point where you can then do a direct substitution, not trivial. That takes some work. We'll stop here because I think we're out of time. So we got through 26. We'll do some more of this next class. We'll continue on into the calculator pieces. That seemed to go a bit better for us than the non-calculator. We'll take questions on things that I didn't go through today, tomorrow. I shouldn't say tomorrow, Thursday. And then if time permits, we'll start the FRQs also. If you didn't get a chance to do part B, or the calculator MCQs, and you're gone, feel free to do those, and if you have time and you want to do them before, and fill out the Google sheet or whatever, and I'll score them.
I had a quick question.